which has a governing body in it called the nucleus. This is the control center, the nucleus. In the cell, you have what are called lysosomes, and there are a bunch of other structures. And you have mitochondria, and mitochondria here and here. These structures are making all the proteins and all of the things you need to survive. They make your DNA, they make your genes, they make all the proteins, and make your CoQ10, they do all that stuff. Well, you know, when you're not a biochemist and you're not in the lab watching the reaction occur, it's just something you have to imagine. Well, today, the way the microscope has been developed, we can actually watch those reactions occurring, and you can actually measure them and quantitate them. I've seen mitochondria come out of the cell and repair a rent in the wall. So to do that, you had to have a microscope that goes really, 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 really to small, infinitesimally small structures. Well, what happens is, when you and I are born, I'm going to use this as a representation. We have a lot of antioxidants being produced by these structures that I call lysosomes that are making our substances. And we have a tiny bit of free radicals. So antioxidants are the yang to this yin. When you have a free radical, it means that it's something that needs to be neutralized and balanced. When we're young, we're making huge amounts of antioxidants because what does antioxidant mean? Something against what oxygen does. Okay? So we need to understand that. But as we age, we make this amount of antioxidants and that amount of free radicals. How does that happen? Well, you take in oxygen, it creates, by the mitochondria, usage in the mitochondria, energy, and that energy we call was in the form of little packets that are called ATP. And you make this energy, and that allows all of that factory to operate. But the side effect is that you're also making free radicals. So let's define that. Free radicals are the side product of oxygen being combusted to make energy, and they are unstable compounds. That's all you need to know. Well, what you need to understand is that if you don't neutralize them right away, they are very hungry to find a place to call home. So they will attach any place in this cell that they possibly can. And if they do, they're going to cause injury because they're in the wrong place. They cause a disturbance of that structure, that entire architecture biochemically and functionally. So that free radical, when neutralized by an antioxidant, doesn't cause us any problems. But guess what? We go through life and we breathe more and more, and we've got pollutants in the air, and we've got chemicals that are not in organic gardening, and what we have is more and more free radicals being produced. So that's how we go from there to here. All right? The question was, what regulates it? And this is where Dr. McCord and the other colleagues of his have been so brilliant in their discovery of a protein that sits in the cell. It's called the Nrf2. Now, if there's an Nrf2, there must be a 1, and I'll get to that in a minute. But Nrf2 is like the sentry that's looking at everything that's going on, and it communicates with the control center. And when we have too many free radicals, this protein, if stimulated, if we activate it, if we free it from its sentry post, sends a message to the control center that says we are now way overwhelmed with antioxidant, with free radicals, and we need to switch our engines back to making antioxidants. And in fact, the control center sends out a bunch of enzymes that we call survival genes and starts turning our engines back to making more and more antioxidants. Okay? Now, why is this important? Because if we don't neutralize the free radicals, you heard Sandra say, you will get inflammation. What is inflammation? Inflammation is the body's response to any injury. It could be streptococcal throat infection, could be a virus, could be a surgeon's incision, could be a chemical in the air. And when you get inflammation, which is trying to repair or do something about that injury, you ultimately end up in a scar. So that's called aging. And that is the entire mechanism at play in the production of all disease. What's disease? Changing normal tissue and normal function to abnormal tissue and abnormal function. So if we can find a way to stop this free radical from being so injurious to our cell by increasing our antioxidant production and by stopping so much scar formation, we're going to delay aging, and we're really cutting oxidative stress down to bare minimum. In fact, if you really look at a chart that Dr. McCord published, you can take any person in this room, and we're at different ages, and you can return the degree of oxidative stress measurable in that patient back to when they were a newborn. So it's not even your age can stop you from improving your health, because you're still breathing oxygen, you're still having oxidative stress. So this is the protein that, when freed from its sentry position, sends a message, and we send out the survival genes, and we start making antioxidants million per second. Not vitamin C, which is a 1-to-1 reaction, not vitamin D, not any of those things, but a million per second, because it's your own body that is activating its own intrinsic mechanism to create the antioxidants. That's phenomenal. To me, and you heard me say it before, it's the greatest discovery in medicine, certainly in my career, and probably one of the top 5 in all of medicine. Well, if you've got a 2, you've got a 1. So here are these mitochondria, here and here, that are constantly making energy, which means they're the factory turning out the energy, right? Well, they got to get tired sometime. You take your car in and have the engine checked. You know, it might need lube, it might need a new timing and pistons and so forth adjusted. The mitochondria get wear and tear on them. So Nrf1, nuclear respiratory factor 1, is a energizer in the sense that it helps to create a healthier mitochondria that is wearing out. It also helps to increase the number of mitochondria, and it therefore will produce a more efficient energy producing organism in the mitochondria. And it's going to also do what? Produce more oxidation, because you're going to be more energy produced. So you've got to take these two basically now in tandem. So the recommended way to take these things is to take your Nrf1, increase the energy level and the productivity of the mitochondria, and a little bit later take your Nrf2. And that way you are dealing with increased energy and production and increased protection by neutralizing the free radicals. If you're going to take just one, I would recommend take Nrf2. If you're going to take both, then you're going to take Nrf1 first and the other second. So this is the whole scheme of why this is so intriguing to me. Not only intriguing, but so important to me. I'm a doctor. My avocation is to help people. Well, who is this product for? Every single person in the world. And every single life form that uses oxygen. And you'll find superoxide dismutase in every life form that uses oxygen, including the plant life. So what we have here is a discovery of a uniformly present biologic cellular function, and we've got the patent on products that will energize both Nrf1 and Nrf2. From a business standpoint, let the businessman talk, but your market's unlimited. From a health standpoint, your market's unlimited. From a result standpoint, I witness it every day. So if you're going to do nothing more then I tell you take the products. And if you're going to get in the business, then you have to understand